Two prompts that look almost identical to you can be completely different to an LLM and cost you differently, and the reasons is tokens. Most people assume one token equals to one word or one token equals to 0.75 words, and that's roughly true. But in real systems, this assumption breaks very quickly, and when it breaks, it directly affects your cost, latency, and context limits. So in this video, I'll help you build a clear mental model of what tokens actually are, why they exist, and how to think about them when building LLM based applications. So let's dive in. Let's start with one important mental reset. LLMs don't understand the text the way we humans do. For example, when you read a sentence like "the cat sat on the mat," we instantly understood the meaning of the sentence. But an AI model cannot read the text directly because it can only process the number. So the first step in working with the textual data is to convert this text into some numerical representation. But before that, we actually need to split the sentence into smaller units, and these smaller units are called as tokens. So how does this actually work? So during the training, we actually create something called as vocabulary, which is essentially a list of known tokens created from the training data. And each token is assigned a unique ID. For instance, the cat might map to 500 or sat to 700 and so on. So now when the model sees a new text, it does three things. First, it splits the text into tokens. Second, it looks up each token in the vocabulary. And third, it replaces each token with its corresponding ID. And these IDs are converted into their numerical representations called as embeddings, which the model can process. Now you might be wondering, why not simply use words instead of tokens, which seems like a natural choice. And in fact, early AI models exactly did that, but it creates some serious problems. Like, since the language is always evolving, so you will always encounter new words. Let's say you trained a model last year and now you encounter a new word, ChatGPT 5.2. And since the model has never seen this word before, so how would they represent it? Because this word never existed in the vocabulary. And this issue is called as out of vocabulary problem. Now, second is when you try to scale the model to support different languages or, include new words which are coming up, this would need millions of unique words, which will actually make the vocabulary extremely large. Another way to think about tokenization is, why not use characters instead of words, because this should solve the vocabulary problem since the character set is limited and every word can be actually built from characters, and that's true, but it creates another issue, which is the sequence becomes much larger. For example, if there was a sentence with 1,000 words, you need to represent it with 5,000 to 7,000 characters. That's like 5 to 7 times more tokens. And this makes the model slower, more expensive, and very hard to train and scale. So character level tokenization doesn't scale either. So we need something in between, something that combines the efficiency of the words and the flexibility of the character. And that's exactly what modern LLMs do. They use something called as Subword tokenization. And the idea is simple. The frequent patterns stay together and the rare pattern gets split. Let me show you this with an example. Let's take these three words: deploy, deployment, and redeployment. So instead of storing each word separately in the vocabulary, the tokenizer learns reusable building blocks. Deploy is one token, ment is another token, and re is another token. Now when it encounters a new word like pre-deployment, it simply breaks it into pre plus deploy plus ment. Now you see the beauty of this approach. We can represent the words even if it doesn't exist in the vocabulary. And this is the foundation of modern tokenization methods like WordPiece or Byte Pair Encoding. Now, since we have understood how tokens and tokenizations actually work, let's see some examples where one word equal to one token approximation breaks. CamelCase and IDs. Let's take this identifier, user session expiry timestamp. It looks like one word, but tokenizer splits this into multiple tokens. So CamelCase, UUIDs, all of these are token heavy because the tokenizer has to slice them into recognizable subword. Second example is the structured data. Here is a tiny JSON payload. It just has two keys and count the number of words. It's 4 or 5. But when you count the tokens, every bracket, quote, underscore, and the numbers gets counted. So the structured data is significantly more token dense than the word count. Third example is the mixed technical language, half natural language, half technical. So the hyphen, identifier, the number, all contribute to additional tokens. So a short sentence in a chat interface can cost you twice of what you would expect. And the fourth example is the non-English languages. And this is one of the most underappreciated problem in global products. Take the exact same sentence sentence and translate it into languages like Hindi, Tamil, or Telugu. And you would see the token count jumps to 5 to 8 times compared to that of English. Why? Because the tokenizer was primarily trained on English text, and the non-Latin text get tokenized at much finer granularity. So if you're building a product that is going to be used globally, you can't use this approximation at all. So I hope by now you understand why the tokens equal to word rule breaks in practice. This approximation only works for clean English, no code, no JSON, no formatting. But the real LLM based system, especially the AI agents, contain system prompt, tool schemas, chat history, RAG documents, different languages, and so on. So my recommendation to you is, if you're designing the LLM based system, start thinking in terms of tokens, not words. Always measure and budget using tokens, and you can even try it yourself using the OpenAI tokenizer tool to see how different input break down. Because the token usage depends heavily on the language, the format, and the type of content. So when you optimize prompt, always remember shorter text doesn't mean fewer tokens. JSON and structured output are token heavy. Code uses more tokens than natural language, and a cleaner looking prompt might result into more tokens. Alright, so once you start thinking in terms of tokens, your cost estimates becomes accurate, your prompt becomes more efficient, and your systems becomes more reliable. So if you found this video useful and learned something today, please do like and subscribe. This really helps the channel. Thanks for watching, and I'll see you in the next one.